Everybody, it's Mrs. Harbin. We're getting ready to have some fun, writing names and formulas of ions, ionic compounds. So here we go. This is one objective we got to do. All right. What should you read from the book? Still chapter 7. All right. Hey, want some bonus? Do some stuff. All right. That's what you got to do. All right. So just to review, what makes what happens when lithium and fluoride meet? Well, lithium can transfer one of its outer electrons to fluorine, and you get lithium fluoride. Okay? Because this is a positive 1 charge, and this is a negative 1 charge. The chemical formula for lithium fluoride is LiF. The name of lithium fluoride is LTHIUM. FLUO. Come on, you guys have a periodic table. Look at how it's spelled and put an IDE on it. So that's how you name an ionic compound. That's how you write a formula. Cancel a charge. So, how do you know you have an ionic compound? You're looking for something that starts with a metal, or it starts with our favorite positive polyatomic ion, ammonium. And then the second part of the compound is a nonmetal or polyatomic anion. So what's this? This is an ionic compound, metal and nonmetal, okay, ionic. This is an ionic compound. It's got a metal and a polyatomic ion, okay. This is not an ionic compound because it's got 2 nonmetals. So this is a covalent compound, right? I won't circle it so you don't think it's ionic. This starts with the ammonium ion and has a polyatomic ion as the anion. So this is ionic, right? This starts with a nonmetal and another nonmetal. So this is not ionic, not ionic. This is a polyatomic ion because it's many atoms with a charge. So it's not ionic. Okay, so ionic compounds have to have a metal and a nonmetal, a metal and a polyatomic ion, ammonium, and a polyatomic ion. Okay, so ionic is a metal ion or ammonium and a nonmetal or polyatomic anion. Make sure you know that. Positives and negatives must cancel because compounds are neutral. So if you see the name sodium sulfide, you should think for sodium Na. And you should think for sulfide, it comes from S. Then you go to the periodic table and figure out the charge. Well, sodium's in group 1, so it has a +1 charge. Sulfide's in group 6, so it has a -2 charge. That and that does not equal 0. We need more of the sodium. All right. Now, these two together in that one cancel to make +2 and -2. So then when we put the compound together, we have 2 sodium ions and a sulfide ion. This is sodium sulfide. That is the only chemical formula for sodium sulfide that there can be because a charge has to cancel. Okay. Remember, balance is the key to life. Just ask that elephant. All right. We'll keep trying. All right, here are some more ionic compounds. How do I know? Metal, nonmetal. All right, so this is ionic. So then when I think calcium, I think Ca. When I think bromide, I think it comes from bromine, Br. Then I check the periodic table. Calcium, +2 charge because it's in group 2. Bromine, -1 charge because it's in that column. Okay, so this does not equal 0. How can I make it equal 0? Well, if I have another one of those, that is -2. That's +2. So the formula for calcium bromide is CaBr2. Okay, calcium bromide is CaBr2. That's all it can be. That's the only way they go together to cancel charge. Aluminum. Right here. Hey, it's aluminum. It's always a +3 charge. Okay. Oxide comes from oxygen. That is an O with a -2 charge. This and this do not equal 0. I don't have enough negative charge. But my negative charge only comes in packs of 2. So now I have -4, so now I have too much negatives. So I need another aluminum. That only comes in packs of 3. Wait a second. I need another oxide. So now I have a total of +6, a total of -6. The chemical formula for aluminum oxide is Al2 because there's 1, 2 aluminum ions, 1, 2, 3 oxide ions to cancel the charge to make it 0. Magnesium oxide. Okay, magnesium's a +2. Oxide comes from oxygen, it's a -2. So it's an Mg and an O because a +2 and a -2 equals 0, so I need one of each thing. Okay, so what do you need? You need a periodic table. What else do you need? You need to know the charges on the ions, and then you make them cancel. Okay, so what if you have polyatomic ions in there, or you have names with polyatomic ions? So sodium again is Na, and always sodium's +1. Acetate is C2H3O2 with a -1 charge. +1 and -1 already cancels to be 0. This is sodium acetate's chemical formula. All right. Magnesium +2. Sulfate, you memorize, is SO4 with a -2 charge. So +2 and a -2 gives you Mg for one of the magnesium ions, SO4 for one of the sulfate ions, because that's its identity. So that's the chemical formula. Aluminum is a +3 charge. Sulfide is SO3 with a -2 charge. Rut-row, +3 and -2 don't cancel, so we need some more sulfite, SO3 -2. That only gives us another aluminum. Okay, that's a +6, so we need another one. Look at all of this stuff I'm writing. But what does this equal? -6. This equals +6, and then you write the formula. You have 2 aluminums, 1, 2. So this down here number tells you how many. We have 1, 2, 3 sulfites. SO3 is sulfite. Wait, I can't just put a 3 next to it. That's when I have to use parentheses and put 3 on the outside to say that I need 3 whole sulfite ions and 2 whole aluminum ions. But you only use parentheses when you need more than 1 polyatomic ion in your compound. Ammonium is everybody's favorite positive ion. Polyatomic ion. Carbonate is CO3 with a -2. That doesn't equal 0, but if I have another one of these, then I have a total of +2, a total of -2. I am ready to write. NH4 is the identity of ammonium, so I have to keep it all there. But I need 2 of them in my compound to make the charge 0, to cancel the charge. How many carbonates? Just 1. So notice, I only put parentheses when I need more than 1 of a polyatomic ion. Oh wait, here's a chemical formula. It's KCN. I know it's ionic compound because this is a metal and this is a polyatomic ion. So how do I write its name? Well, here's how you do it. You write the name of the first part, the name of the cation, potassium. Spell it right. You have a periodic table. CN is a polyatomic ion cyanide. Cyanide. This is potassium cyanide, and as soon as I erase and put the IDE there, that's the name of that compound. Okay. Hey, here's another compound. I know it's ionic because it's got a metal and a polyatomic ion. So I name the metal barium. You have a periodic table. Use it, find it, do it. All right. This part of the compound is a hydroxide. Okay. So that's all I have to do is write its name. Now you might be wondering, what about that 2? Don't you have to do something with it? The 2 is there because barium has a +2 charge and each hydroxide is a -1. So I need 2 of the hydroxides in the compound. So the compounds are put together to cancel charge. The names just tell you the cation and the anion. All right? So is there any exception to that? Well, there are because, well, first of all, here's how you write formulas for ionic compounds. First, you recognize that you're starting with a metal or ammonium. You have to recognize it's ionic. Then make sure you know the charges on each ion. Then use enough ions to make sure the positive equals the negative, so it's 0 overall. When to use parentheses? Only to keep the polyatomic ions together if there's more than 1 that you need to cancel charge. The compound formula shows no charges when it's done because there are enough of each ion to cancel that. Cancel that, cancel that, cancel that what? Cancel that charge. Okay. There's something else I need to tell you about, and it's Roman metals. Those are the metals that are not always the same charge. So, how do you know that's a Roman metal? Well, it's not an always metal. And so you know it could have variable charge. If I give you the name, I have to tell you what Roman numeral it is, what charge it is. Meaning I'm going to tell you how many electrons it lost. Okay? Here's what the Roman numerals mean. You won't go over 8. All right? So, here's an example. Iron 3 chloride. Iron is Fe. This 3 tells you that it's a +3 charge. This 3 tells you how many electrons it lost. It lost 3, so that's why it's a +3 charge. Chloride comes from chlorine, and it's on the periodic table. Oh, it's going to go here for the periodic table, but it's not there. It's in the group that's -1. So now that I know the ions and their charges, I got to cancel them. 1, 2, 3 chlorides equals -3. 1 iron is +3. So you write FeCl3 for the chemical formula of iron 3 chloride. Write the formula by canceling charge. So that's what I did here. I did the +3. How do I know it was +3? Right there. It tells me so. Chloride. But I need 3 of them. And I get FeCl3. Okay. So, more Roman practice. Copper 2 oxide. Copper is not always metal, so it tells me the charge Cu +2. Oxygen comes from oxide. Oxide comes from oxygen. +2 and a -2 gives me lets me know that there's one of those and one of those. Copper 1 oxide. Hey, wait, something different. This has a +1 charge. Oxide has a -2 charge. So we need another copper ion to cancel the charge. Cu2, two of those. Oh, down numbers are counting numbers. Tells you how many what? How many copper ions. Titanium, IV is 4. Titanium is Ti. 4 is plus 4. Bromide is Br. I know it's -1 from the periodic table. Get yours now. All right. Plus 4 and -1 does not equal 0. That's plus 4 and -2. That's still not 0. Plus 4 and plus 4 and -4 equals 0. So then, can write Ti, and then 1, 2, 3, 4 bromides, Br, 4. This 4 tells me how many Br ions are in this compound. Potassium nitrate. How do I know it's an ionic compound? Potassium is a metal. It's got a +1 charge because it's in group 1. Nitrate you memorize is NO3 negative, nitrate. NO3 negative, nitrate. +1 and a -1 already equals 0. So I could just write the chemical formula. Lead 4 carbonate. How do I know this is not an always metal? Because it has a charge there, Pb +4. Carbonate, CO3 -2. This does not equal 0. I got another one of those. Now I have 4 positive, 4 negative. That equals 0. So it's Pb, and I need 1, 2. I need to tell you how many. I need carbonate in my compound, CO3, but I need 2 of them. So I put a 2 on the outside of parentheses. All right, so what if you are given these and you need to write their name? Well, look at this, CuCl2. Metal, non-metal. This is an ionic compound. Write the name of the first thing, copper. Write the name of the second thing, making it IDE, chloride. But wait, check to see if your metal is an always metal. Copper is not always. So that means I need a Roman numeral to tell me the charge. So I take it apart. I got 1 of those and 2 of those. I know the charge on chlorine is always -1 when it's an ion. So this is -2. That means copper must have been a +2 because someone put this together to cancel charge and it canceled correctly. Okay. Cobalt is a metal. Nitrate's polyatomic ion. This is ionic. Write the name of the first part, cobalt. Write the name of the second part, nitrate. Then ask yourself, self, is this an always metal? Oh, no, it's not always. So I'm going to take it apart. There's a nitrate and another nitrate. Why am I writing it twice? Because that tells me. Charge on nitrate I memorize is -1. So this is a total of -2. There's only 1 cobalt in the compound. In order for this to equal 0, this had to be a +2. So I know this is a Roman numeral 2. AuNO3, metal polyatomic ion. All right. So I name the first part gold. You have a periodic table, use it. I name the second part nitrate. And then I say to myself, self, is this an always metal? No, it's gold. It's not always the same charge. So I take it apart. I have 1 of the nitrate ions, 1 of the gold. What's the charge on the nitrate? Always a -1 because it's nitrate. So gold must be a +1, so I need a Roman numeral of 1 there. Fe2O3. What? Fe2O3. Hey, look, it's a metal and a nonmetal. So I write the name of the cation and the name of the anion is oxygen, so it's oxide. All right. So it's from the periodic table, you IDE it. Right? Then I say to myself, self-iron is not an always metal, so I need a Roman numeral. Okay. So I know there's 3 oxygens. So I write 1, 2, 3 of them, 3 O's, and 2 Fe's. How do I know? The little number subscript tells me how many of each. So I write them down. I know oxygen's -2. Check your PT, you'll find it's -2. So my total on my negative side is -6. So that means in order for that to have canceled, this had to be +6. This is +6, that was a +3, and that was a +3. Okay, so this is +6, that's -6. The Roman numeral is the charge, so this is the iron +3. Okay, metal, polyatomic ion. Write the name of the metal. Aluminum. Aluminum. Use the periodic table, spell it right. NO2 is nitrite. Nitrite. Careful. That's why we're memorizing them, to find them. Then you say to yourself, self, is this an always metal? I say, oh, yeah, it is. Aluminum is always a +3. So do I need a Roman numeral? No, because it's always a +3, always. So I don't need anything next to it because I know it's a +3. All right, so PbCO3. Metal, polyatomic ion. Name the metal. The metal's name is lead. Name the polyatomic ion. Carbonate. Lead carbonate. All right, is lead an always? Nope. It's not aluminum, it's not zinc, it's not silver, and it's not in group 1 or 2. So it is Roman. So I need a Roman numeral. So I take this apart. CO3, CO3. Why am I writing it twice? Because there's a 2 there. And then I have 1 Pb in that compound. So then I say to myself, self carbonate's a -2. Always. Well, carbonate's a -2. That's its identity. so it's total -4. That means over here, lead must have been a +4. There's only one of them, so it's a +4, so it's IV. Okay? All right, so here's the time to review, and we'll have fun reviewing. Okay? So we have to memorize our ions for sure. Make sure you know that the always metals always lose the same number of electrons. So group 1 is always a +1. Group 2 is always a +2. Aluminum +3, zinc +2, silver +1. Memorize your always. The Roman metals are roaming around with their charges. They have to have a Roman numeral in their name to tell us the charge. Cancel charge to write the formulas. Name cation. Use a Roman numeral if it's not always, and name the anion. So this is write the formula. This is write the name of ionic compounds. We can do it all because we're reading from the book, doing some bonus, having fun, and see if we can do this. We will practice 5,000 of them or more or a little less. Peace out.